For years, Linux has been quietly transforming the technology world behind the scenes. While most people associate Linux with programmers, servers, or tech enthusiasts, the reality is far bigger. Today, Linux powers the majority of the internet, dominates cloud computing, runs billions of Android devices, controls supercomputers, drives smart TVs, and forms the foundation of countless embedded systems. Yet, despite this incredible influence, Linux has often remained invisible to the average computer user. Now, however, something different is happening. Many technology observers believe the Linux revolution has entered a new stage, what could be called Phase 2. This isn't simply about Linux existing in the background anymore. It's about Linux moving closer to the center of mainstream computing, in ways that were difficult to imagine just a decade ago. To understand why this matters, it's important to look at the first phase of the Linux revolution. The initial phase was largely about proving that open-source software could compete with proprietary alternatives. In the 1990s and early 2000s, Linux was often dismissed as a hobbyist operating system. Large companies viewed it as interesting but risky. Critics argued that software developed by volunteers could never match the quality and reliability of products built by billion-dollar corporations. Over time, Linux proved those assumptions wrong. Major enterprises adopted it. Governments embraced it. Universities relied on it. Eventually, even some of the world's largest technology companies built their businesses on top of Linux. The cloud computing boom accelerated this trend dramatically. As companies moved workloads to the cloud, Linux became the default operating system for servers. Amazon Web Services, Google Cloud, Microsoft Azure, and countless hosting providers all depended heavily on Linux infrastructure. Developers appreciated its flexibility, security, and efficiency. Businesses appreciated reduced licensing costs and freedom from vendor lock-in. By the late 2010s, Linux had already won many of the most important battles in enterprise computing. But Phase 2 is different. Instead of focusing primarily on servers and infrastructure, the conversation is shifting toward user experiences, consumer devices, gaming, artificial intelligence, and modern development workflows. Linux is no longer just a back-end technology. It is becoming increasingly visible to everyday users. One of the biggest catalysts for this transition has been the gaming industry. For years, gaming represented one of Linux's weakest areas. Most major games were developed exclusively for Windows, and gamers often viewed Linux as an impractical choice. That perception began changing when Valve invested heavily in Linux technologies. The development of Proton allowed thousands of Windows games to run on Linux with impressive compatibility. The Steam Deck further accelerated adoption by demonstrating that a Linux-based gaming device could deliver an excellent user experience. The success of the Steam Deck surprised many industry observers. Instead of creating yet another Windows handheld, Valve chose Linux as the foundation. More importantly, users embraced it. Millions of gamers discovered they could play popular titles without relying on Windows. This achievement wasn't just significant for gaming. It proved that Linux could provide a polished, consumer-friendly experience while handling demanding workloads. Another major driver of Phase 2 is the growing dissatisfaction many users feel toward traditional operating systems. Some consumers are frustrated by increasing subscription models, mandatory online accounts, invasive telemetry, and advertising integrated into commercial software platforms. Linux offers an alternative vision. Users retain greater control over their systems. They can customize interfaces, choose their preferred software, and avoid many restrictions imposed by proprietary ecosystems. At the same time, Linux distributions have become dramatically easier to use. Installing Linux today is nothing like the experience of 20 years ago. Modern distributions such as Linux Mint, Ubuntu, Fedora, Zorin OS, and Pop! OS offer intuitive installers, attractive interfaces, extensive hardware support, and large software repositories. Many tasks that once required command-line expertise can now be completed through graphical tools. This accessibility is lowering barriers for newcomers and making Linux a realistic option for ordinary users. Artificial intelligence is also playing a fascinating role in this new phase. The AI boom has increased demand for high-performance computing environments, and Linux remains the preferred platform for many AI researchers, developers, and organizations. Most AI frameworks, machine learning tools, and large-scale training systems operate most efficiently on Linux. As AI becomes a central part of modern technology, Linux continues strengthening its position as the operating system of innovation. Interestingly, AI tools are making Linux itself easier to use. New users can ask AI assistants for help with commands, troubleshooting, and system configuration. Tasks that once required hours of forum searches can often be resolved in minutes. This reduces one of the traditional challenges associated with Linux adoption and makes the platform more approachable for beginners. The rise of containerization and modern software development practices represents another key aspect of Phase 2. Technologies like Docker and Kubernetes have transformed how applications are built, deployed, and managed. Linux sits at the center of this ecosystem. Developers increasingly work within Linux-based environments, even when using other operating systems. Many software teams standardize around Linux workflows because they provide consistency across development, testing, and production systems. This trend creates a powerful feedback loop. As more developers become comfortable with Linux, more software is designed with Linux compatibility in mind. Better software support attracts more users, which encourages additional investment and innovation. The ecosystem becomes stronger with each cycle. Hardware support has improved significantly as well. Historically, hardware compatibility posed challenges for Linux users. Finding drivers for printers, graphics cards, Wi-Fi adapters, or specialized peripherals could be frustrating. Today, many hardware vendors actively contribute to Linux support. Companies such as AMD have earned praise for their open-source driver efforts. Major laptop manufacturers now offer Linux-certified systems. Some vendors even ship computers with Linux pre-installed. The growing interest in privacy and digital sovereignty is another factor fueling the revolution. Around the world, individuals, businesses, and governments are becoming more conscious of data ownership and technological independence. Open-source software offers transparency that proprietary systems cannot easily match. Organizations can inspect source code, verify functionality, and avoid dependence on a single vendor. For many decision-makers, this level of control has become increasingly attractive. Education is also contributing to Linux's momentum. Students entering technology fields frequently encounter Linux early in their learning journeys. Universities teach Linux administration, programming, cybersecurity, cloud computing, and networking using Linux-based environments. As these students enter the workforce, they bring familiarity and confidence with Linux systems. Over time, this influences organizational technology decisions. Meanwhile, cybersecurity concerns continue driving interest in Linux. No operating system is immune to security threats, but Linux benefits from a development model that encourages transparency and rapid response. Security researchers, developers, and community members continuously review code, identify vulnerabilities, and contribute fixes. This collaborative approach has helped establish Linux as a trusted platform for critical infrastructure. Perhaps the most interesting aspect of Phase 2 is that it does not necessarily require Linux to dominate desktop market share. Traditional discussions about Linux often focused on whether it could surpass Windows or macOS on personal computers. While desktop growth remains important, the modern technology landscape is far more diverse than it once was. Linux already dominates many categories that barely existed 20 years ago. Cloud platforms, containers, edge computing, IoT devices, AI clusters, and handheld gaming systems represent enormous opportunities where Linux is already thriving. In many ways, Linux has evolved from being an operating system into a foundational technology platform. It powers innovation across industries from healthcare and finance to entertainment and scientific research. The question is no longer whether Linux is relevant. The question is how deeply Linux will shape the future of computing. The role of large technology companies adds another layer to this story. Ironically, some of the corporations that once viewed Linux as a threat now depend on it extensively. Microsoft contributes to Linux development. Google relies on Linux throughout much of its infrastructure. Amazon builds cloud services around Linux technologies. This shift demonstrates how thoroughly Linux has become integrated into the modern technology ecosystem. Community-driven development remains one of Linux's greatest strengths. Unlike many proprietary platforms, Linux benefits from contributions made by individuals, universities, nonprofits, startups, and multinational corporations. This diversity reduces dependence on any single entity and encourages innovation from multiple directions. New ideas can emerge from anywhere and rapidly influence the broader ecosystem. Looking ahead, several trends could further accelerate Phase 2. The growth of ARM-based computing, the expansion of edge computing infrastructure, advances in open-source AI models, improvements in Linux gaming, and increasing demand for privacy-focused technology all create opportunities for Linux adoption. As these trends converge, Linux is positioned to benefit from multiple technological shifts simultaneously. What makes this moment particularly exciting is that the Linux revolution no longer feels like a niche movement, driven solely by enthusiasts. It is becoming a practical choice for gamers, developers, students, businesses, creators, researchers, and everyday users. The ecosystem is more mature than ever. The software selection is broader. Hardware compatibility is stronger. User experiences are more refined. Support resources are more accessible. The Linux revolution's first phase was about survival and legitimacy. Linux had to prove it could compete. It had to demonstrate reliability, scalability, and value. That mission has largely been accomplished. Linux powers critical systems across the globe and forms the backbone of modern digital infrastructure. Phase 2 is about expansion, visibility, and influence. Linux is moving beyond the server room and becoming a more prominent part of everyday computing experiences. It is helping define how applications are developed, how games are played, how AI systems are trained, and how organizations think about technology ownership and control. Whether or not Linux ever becomes the dominant desktop operating system may ultimately be less important than many people once believed. The real story is that Linux has become a central force shaping the future of technology. The revolution is no longer about proving Linux belongs. The evidence is already everywhere. The revolution has entered a new phase, and its impact is only beginning to be fully understood.